Okay, when I move ahead now, we are looking at software engineering in terms of financial engineering developments that we plan to do. So first, we'll start it by looking at what we have in software engineering, the topics there. Based on those topics, we will try to filter out topics that would help us in the development of these financial engineering engine or simulation software or tool pack. So if you look at the syllabus, we have in the starting part of software engineering, we have the generic view of process. It's a layered technique, a process framework, a maturity model modeling. Then we have process models, which is waterfall, incremental process, the RAD model, evolutionary process model, which is prototyping, the spiral model, the concurrent development, the final development. An agile view of process, what is agility, the agile process model, XP, ASD, DSM, Scrum, FDD, AM. Requirement engineering, brigade between design and construct, requirement engineering, inception, action, negotiation, specification, requirement. So practice, the essence of practice, core principles, process planning, model planning, principle, design, modeling principle, construction practice. Then we have design engineering, design concepts, abstraction, architecture, pattern, modeling, information hiding. System engineering hierarchy, system modeling, simulation, system. Now look at the system engineering. This overlaps with the MIS topic. We have creating an architectural design, a data design at an architecture level and component level. Testing strategy, testing tactics, building the analysis framework, and data modeling concepts. So this is how structure here is built up upon. Again, if you make it smaller, the core areas of software engineering course or module is the process design, the generic view of process, evolutionary process model, agile view. If you look at some keywords, agile means flexible, so you can actually be flexible on the software engineering development that you are doing. Evolutionary is keep on evolving and adding things. Requirement engineering is more of client oriented or what customer wants. Then some practices, design engineering, system engineering, and abstraction and architectural design, also known as abstraction layer, things that comes here is about creating the right abstraction layer. You don't want to be too much technical so that the customer don't understand. So it's all about developing the right software and the various theories and the ideas that people have given on how to develop very good parts. So if you don't follow them, then you might not be able to coordinate things well. A more broader sense would be a system engineering point of view, which is this one, where you look at management, cash flows, the economic factors, the organizational view, and get what you want to actually build, and keep those things in mind. Then we have testing strategy and building analysis model. Let's jump in the first part to understand what's happening here. So a program versus software engineering framework. This is not the very thing that we are looking at, but then you have developing of manual. In the first part, you talk about the myths. This is misconceptions that you have. The thing that starts that becomes more important is a generic view of process. Now you are doing some few steps versus you have a software that does that. So software is it should take care of all things that could happen and all concepts or ideas that the customer might give in between. So those are the two things that becomes important. So software engineering is a layered approach. You have various layers where you hide in some information. Those things which should not be shown should be kept away. At the same time, it should be consistent. Then you have process, framework, and so on. So construction of software involves a lot of activities. The gradual development and evolution. The life cycle has several phases. Number of process models for developing software. So in general, any problem solving software must consider activities like requirement specification, deciding a plan for solution, coding, and testing the verification process. Layer technology, talk about process layer, method layer, and tool layer. A process framework is a guideline, concept, or best practices that describes how things would go. When we move further down, this is the software process. So product engineering process, process management process, development process. So in the software process, software specification, software development, software evaluation. The software process model, there is a workflow model, data flow activity, and relocation model. Just look at the words here. They sound quite similar if you look at them in the first time, but they have a very small conceptual difference. So the software process, then you have software process models, Uh, and these are models that come along many times. So waterfall, this takes the work to represent them as separate process phases. This is requirement specification, software design, testing, and so on. After each stage is signed off, development goes on to the following stage. The evolutionary development interleaves activities specific development relation. Initial some rapid level by abstraction, then is refined and custom input storage system is satisfied. The system may be delivered, alternate may be implemented using more structural approach. A formal transformation, if you have a formal mathematics specification. Then you have a system assembled from reusable components. This technique assumes that the part of system already exists. The system. So these are the general model or paradigms of software development. A waterfall, evolutionary, formal transformation, and system assembly from reusable component. As the name suggests, it's quite easy to depict them. Then you have a characteristic of formal, which is predictability. New process improvement, software development life cycle. This is an important part. How you would design, code, test, and do all those things. Process development specification model. A step in the development process. So entry criteria input. When we have done your capacity maturity model is not used to develop and refine organization software process. The model describes the 5-layer evolutionary path of increasing organized and systematically mature process. CM was developed and promoted by Software Engineering Institute and Research Development Center in 1984. So the purpose of CMMI is that it is a framework that describes key elements of active process. It provides a foundation for process improvement. The CMM describes an evolutionary improvement path from an ad hoc immature process to a mature process. The process describes the CMM. It shows 5 levels of progressive maturity: initial, repeat, define, manage, optimize. The CM covers practices for planning, engineering, management, development, and activity. When followed, these key parameters of evaluation. So there is a yardstick against which is possible to judge in a repeatable way. So the SCS software process capability maturity model. Just remember the name. It's SEI. This is an organization software process capability maturity model. Initial, repeatable, defined, managed, and optimizing. So these are the 5 maturity level of software process. So the initial, then project management, then engineering process, then continuous process improvement. Level 1 to level 3, and then optimization. So this is how you can look at. Then you have a case study here. This case study is basically what we would be doing in our financial engineering course. You have some full forms that would come important. So the computer-aided design capability maturity model is what we do. Department of Defense. Now most of the internet thing came from the Department of Defense. Objective in software process. Software Engineering Institute. It's an institute that was established some time. Statistical process control. Software process improvement. This was the first really part. Then the other would be the process models. So the models that we used, the waterfall model was the front runner, which was required in military application. It is a rated system where the buyer is a sophisticated about computer, etc. So both knows a lot of things. So prototyping is popular. User-friendly software. The software is historical as maintainable and so-called big iron applications are using waterfall model, incremental model. No notion is the spiral model is more recent that tries to enjoy the best of both worlds. These are the common features. So those were the things in the software in the waterfall model, which is quite important. And the limitation in the waterfall and incremental model and the RAID model, the full form. In the RAID, you have a rapid application development, which is quite fast. Which is a full form is a concept that faster and high quality. So gathering requirement, prototyping, early rated design, the use of software components, replace version. So that was about the RAID model, business modeling, data modeling. So based on what and where you stand, you would use a particular model, and based on the resources, the cost, the timing. So these are just general ideas that would help you when you go there and when you want to look at things. So that was the model. Then we have evolutionary process. Evolution is something that's quite interesting in software engineering. So this model is iterative. It comes back as the characters management and software engineer develop increasingly more complete version of the more software. So the loop that goes on and on, as the name suggests, it's more of an evolutionary model. The prototyping model. So waterfall have sub-constraint. We study to counter this problem. The goal of the is to counter the first tool in place order. The basic idea is the freezing requirement, defining its sign coding. We will to help understand requirement. This process is developed based on current requirement, developing or prototyping obvious and design, but easy is not very fun. What is the basic idea? The basic idea here is to freezing the requirement before designing can proceed. A thorough prototype is able to understand the requirement. So the basic idea here is that instead of freezing the requirement, the throwaway prototype is built to understand the requirement. So the prototype is an attractive idea for complicated large system, and so on. So the process is used for as follows. That was about the prototyping model. The spiral model is, you can see, it's a kind of a spiral. So acceptance, integration, unit code, operational risk analysis, and it likes come again and again and again. Then a case study. Then you have agile view of the process, extreme programming, adaptive software development, DSM. So agile, the basic meaning of the word is flexibility, and these are all the terms that that depict what is an agile process. So you hear these terms more often: agile Six Sigma, which means you are flexible and you do very less of errors. So you study those kind of things on to catching the error, and you are flexible in your, then you have requirement engineering and so on.